Hello everyone. So today in this video I'll be discussing jaan kalda handout, that is mechanics problem, which is question number 25. Question number 25 is a mixture of chapters from Newton laws of motion, work energy theorem, rotation and other chapters. It will also involve a bit of frame of reference of the accelerations. Without further discussions, let's get started. It says a uniform rod of length L is attached to a weightless thread to the ceiling at point A. The bottom end of the rod rests on a slippery floor at point B, which is exactly below A. Length of AB is h. The rod begins to slide from rest. Find the maximum speed of the center during the subsequent motion. Also find the acceleration of the rod center and the tension in the thread at the moment when the rod speed is maximal, if the rod's mass is smaller. Okay, so let's just first find the maximal speed. For maximum speed, we need to use work energy theorem. This much we know. Now the height descended should be maximum. This is my first condition. And the second condition is that the rotational kinetic energy, that the kinetic energy due to rotational motion of the rod would be zero, then only we can make the linear speed to be maximum. Now observe this diagram. As said in the diagram, the rod is initially forming an isosceles triangle. Now, finally, if the rod descends by a height such that the thread exactly becomes vertical, then what happens? Basically, the height descended is maximum. Height descended is maximum in this case, right? So first condition is satisfied. Now the second condition is we have to minimize the rotational kinetic energy. Now observe one thing, that when the thread is vertical, then the velocity of this point would be along the horizontal, that will be some velocity v, and this other point, that is end b, is constrained to move in the horizontal plane, so it will also have the same velocity v. Thus omega of this rod is 0, hence rotational kinetic energy would come out to be 0 in this case also. Thus using basic work energy theorem, this length is smaller, this will be h minus L, and the center of mass is at a distance h minus L by 2 from the ground, and initially the center of mass is at a distance h by 4, so hi is equals to h by 4 and hf is equals to h minus L by 2. So what is the descent? Descended is equals to hi minus hf, which will come out to be 12 minus h by 4. Now applying basic work energy theorem, we will get half mv square is equals to mg into 12 minus h by 4. So cancelling out the 2's, and you'll get v is equals to under root g into L minus h by 2. And that's the answer to the first part. Hence the first part, that is the maximum speed, is found out. Now second is we have to find the acceleration of the rod center and the tension in the string at the moment the rod speed is maximal if the rod's mass is m. Now second part is basically telling us to deal with some dynamics. What happens here at this point is, suppose this is my string and this is my rod and this is the floor. For now I assume this angle theta, which says that sine theta, you can write it as h minus L by L. Okay, since this is L and this is h minus L. Now for instance, suppose the tension in this point be T and the normal from the floor be N. Now I'll be writing the second law of motion. Now one thing we have to observe is, before writing the second law of motion, is that the acceleration of the rod's center of mass will be along the vertical direction, because forces are all along the vertical direction and there will be a mg in the downward direction. Now what will be acceleration of this point A? Acceleration of point A along the vertical direction will be u square by L, since we know that for polar coordinates the acceleration is written as r double dot minus r theta dot square. Since r double dot is 0 because the string should not slack, so the velocity of point A, one component along the vertical direction would be u square by L or v square by L, since we substituted v as root g into L minus h by 2, something like that expression come for the velocity L minus h by 2. Yes, with one acceleration will be v square by L along the upward direction. Suppose acceleration of A along the x-axis be ax. I don't know the value of ax till now, and the angular acceleration of the rod be alpha. Okay, and the direction of alpha be this side, that will be alpha. Now with respect to A, the acceleration of the center of mass you can write is alpha L by 2, and acceleration of the bottommost point B is alpha L. Now what will be the acceleration of the bottommost point in the ground frame? It will be the acceleration of A plus acceleration of the bottommost point B with respect to the acceleration with the respect to frame of A, and we are considering A to be a translational frame instead of rotation. So there would be some addition of AX and V square by L. Now observe one thing, that point B is constant to move in the horizontal plane. So the acceleration of point B with in the vertical direction should be 0. Hence alpha L cos theta should be equals to V square by L. This is equation 1. This is another important equation. And center of mass acceleration along the x-axis is 0. Hence I can say that Ax is equals to alpha L by 2 sine theta, right? So you get two important equation as per I can see. Now alpha L can be written as V by L, so you can write it as V square by 2L tan theta. Now writing the required values, that is the Newton's laws of motion, we'll get T plus N minus mg is equals to m ay, and ay can be written as m times of u square by L minus alpha L by 2 sin theta. Well, we already derived that alpha L by 2, 1 minute. Yeah, it will be alpha L by 2 cos theta. Sorry, it will be alpha L by 2 cos theta, and substituting those values, you will get m v square by 2L is equals to T plus N minus mg. This is equation 1. And second equation will be acceleration, angular acceleration equation. And since we consider angular acceleration to be clockwise in direction, so I can write T minus N into L by 2 cos theta is equals to m L square by 12 alpha. Cancelling all the required terms, I'll get T minus N is equals to m alpha L by 6 cos theta. Right? No, there will be a cos theta in the numerator. So the cos theta will come in the denominator, and we already derived alpha L in the previous section, that v square by L cos theta. Just I'll substitute it. I will get v square by 6L cos square theta. We know we already derived the value of v square. It will come out to be g into L minus h by 2 upon cos square theta can be written as 1 minus sin square theta, and sin theta is equals to h minus r by h minus L by L, and cos square theta can be written as 1 minus h minus L whole square by h minus L by L whole square. And if you substitute those values, you will get the expression coming out to be T minus N is equals to mgl by 12h. Similarly, T plus N is equals to mg plus mv square by L m into g L minus h by 2 upon n L. And I guess I'm missing some factor. Yeah, it will be at another 2 here, it's given. Now just adding both the equations, I'll get 2t is equals to mg into, and taking common mg by 2, I'll get 3 plus 3 plus minus h by 2l plus l by 6h. From here I'll get tension is equals to mg by 2 3 minus h by 2l plus l by 6h. Hence that's the answer. So I have found out everything you required in this problem, and you can find a of the center of mass as a is equals to v square by 2l, which will come out to be I guess g by 2 into 1 minus h by 2l. Hope you get the problem, and this question basically tested your understanding about the acceleration in different frame of references, and how can you think of the problem that how to maximize the velocity, because when the velocity is maximum, all the conditions are satisfied, that is the height descended is maximum and the rotational kinetic energy is also zero. That is why we could confidently say that the translational kinetic energy at this moment would be maximum. Hope you got this problem. Thank you, have a nice day.